In part 3 of lecture 6, we will discuss constructing the initial state of an LR0 state machine. It's probably a very good idea to take a moment and be sure that we are comfortable with a few terms that we will see a lot of, starting with one that we have seen before, a sentential form. A sentential form is a partially formed sentence or program. What distinguishes it from a sentence is that while a sentence contains only terminals, a sentential form will contain a mixture of terminals and non-terminals. We are usually talking about right sentential forms because they are on the right-hand side of a production. In a context-free grammar, we will never see a terminal on the left-hand side of the production. Right sentential forms are derived from the rightmost derivation, and formally, if we say S ultimately derives beta, that means that beta is a right sentential form. When we are performing a reduce operation, we have to decide which variables in a right sentential form will be popped and replaced on the stack by the non-terminal that describes the production's left-hand side. These variables on the right-hand side of the right sentential form are collectively called the handle. If A derives beta, then beta would be the handle for the production. An item is a production with one big difference. A dot is added so that we can see how much of the production has been matched up to what is found in the program. For example, if I were to see E derives dot E plus T, this tells me that nothing in the production has been matched so far. On the other hand, if I had E derives E plus dot T, this would tell me that I've matched up the E and I matched up the plus, and I have not yet matched up the T. Given our prior experience with finite automata, we might expect that our state machine would look something like this. But that's not going to be the case. In the case where we were looking at regular expressions, everything that we had was quite literally in front of us. But there are many digressions that we will need to make, and many returns from those digressions, if we are going to be parsing a context-free grammar. So our state machine is going to look quite different from this. We already know that processing context-free languages will require a push-down automaton. Let's take a look at an example to start with. As we prepare to match tokens to the item S derives dot E dollar, the dot there tells us that we are about to process the non-terminal E. But we have no way of knowing yet what tokens we are going to encounter and when we will be finished finding all the things that will represent an expression in this case. What that means is I need to take a look at all of the possible ways of representing an expression, which in this case will give us the initial items E derives dot E plus T and E derives dot T. So in other words, I know that I'm going to have to substitute for E one of these two expressions, and we'll go on from there. The fact that we have the item E derives dot T means that I need to know the different ways that I could find the non-terminal T. There are three additional items that need to be added at this point. T derives dot plus F, T derives dot minus F, T derives dot F. The first two cases will not require any additional items because I know what I'm looking for when I'm looking for a plus or I'm looking for a minus. In the case of a non-terminal like F, it could be in this particular grammar an identifier or a constant, so I don't know as of yet what that's going to be. The item for T, T derives dot F, means I need to know what I will see if I'm looking for a factor. For that reason, I need to add initial items fderives.id and fderives.const. So if I am going to match an identifier and a constant, I know that this will give me what I'm looking for as I look for a factor. I will start constructing the state machine with the initial state. The special start symbol derives dot the regular start symbol and the file marker. In this case, the regular start symbol is E for my expression grammar. S is going to be the special start symbol. Given that the dot is in front of a non-terminal, I need initial items for E. In this way, I will add ederives.e plus t and ederives.t. Now, given that ederives.e plus t is recursive, this does not require any additional items. However, ederives.t means I will now need initial items for t. Here you'll see the 3 initial items for t. T derives dot plus f, t derives dot minus f, t derives dot f. Dot plus dot minus has the dot right before a terminal. I know exactly what I'm going to be seeing in these cases, and I don't need any additional initial items. But the f means that I need initial items for f. Having the dot immediately before the f means I need initial items for f. F dot identifier and f dot const. In both of these cases, the dot is followed immediately by a terminal, so I don't need any additional items beyond these. This is the final result of our first stage. We now have an initial state for our LR0 state machine.